A single dinosaur could eat more food in one day than an entire family eats in a month. Not because it was greedy, because it had no other choice. For over 150 million years, dinosaurs solved one of the hardest problems in biology. How do you fuel a body that big without a single bite of the food you or I would recognize? And the answer is stranger and more clever than almost anyone expects. Let's start with the giants, because they had the hardest math problem on the planet. A sauropod, like Argentinosaurus, could weigh over 70 tons. To keep a body that size running, scientists estimate some of the largest sauropods needed to eat somewhere around 1,000 pounds of plant material every single day. Not once, every day for decades without stopping. That's roughly the weight of a small car in leaves, needed just to stay alive until tomorrow. So what was actually on the menu? Ferns, conifer needles, cycads, horsetails. None of it was rich in calories the way fruit or grain is. Most of it was tough, fibrous, and low in nutrition, which meant the only way to survive on it was volume. Massive, constant, non-stop volume. Sauropods weren't eating meals. They were running a conveyor belt. And here's the first real problem with that plan. Look at a sauropod's skull, and you'll notice something missing. Almost no chewing teeth. Just simple peg or spoon-shaped teeth at the front, built for stripping leaves off branches, not grinding them down. Which raises an obvious question. If you can't chew 1,000 pounds of tough plant matter, how do you possibly digest it? The answer is one of the strangest adaptations in the entire animal kingdom, and it's sitting in their stomachs. Gastroliths, stones. Some sauropods swallowed rocks on purpose, smooth, rounded stones that sat inside a muscular part of the digestive tract and ground up plant material from the inside, essentially replacing the chewing they skipped entirely. Some fossil sites have preserved these stones still clustered exactly where the stomach would have been, polished smooth from years of grinding leaves into paste. Your stomach breaks down food with acid. Theirs did it with a built-in rock tumbler. Now, compare that to something like Stegosaurus or Triceratops, and the strategy flips completely. These dinosaurs had rows of specialized teeth built for actual chewing, some species packing hundreds of small teeth into tight batteries that ground plant material down mechanically before it ever reached the stomach. Different problem, different solution. One group swallowed rocks to do the grinding internally. The other built an entire mouthful of built-in millstones to do it before swallowing it all. But plant eaters are only half the story, and the meat eaters raise an even stranger question. How do you actually know what a predator that's been extinct for 66 million years was eating for dinner? The answer is almost unbelievably specific. Fossilized dung. Scientists call it coprolite, and it's exactly what it sounds like. Preserved droppings, sometimes perfectly intact for tens of millions of years. Cut one open under a microscope, and you can find crushed bone fragments, plant material, even identifiable pieces of the last meal a dinosaur ever ate. One famous coprolite, believed to be from a Tyrannosaurus rex, was found packed with crushed bone fragments from a young plant-eating dinosaur. Direct, physical proof of exactly what ended up on the menu that day. And bite marks tell an even more direct story. Paleontologists have found dinosaur bones with tooth punctures still embedded in them, sometimes with broken predator teeth left behind inside the wound. Match the spacing and shape of those punctures to a specific species' jaw, and you can reconstruct, almost frame by frame, exactly which predator was eating which prey, in some cases even which part of the body they went for first. Here's where it gets genuinely surprising, though.
Some of that bite mark evidence doesn't point to predator versus prey at all. It points to something else entirely. In several T-Rex specimens, scientists have found tooth marks on the bones of other T-Rexes, gouges that match the spacing of their own species' teeth. The evidence increasingly suggests that when food ran short, or when a rival was already dead, T-Rex was willing to eat other T-Rex. Not hunting each other necessarily, but not passing up a meal either, even if that meal used to be family. And T-Rex wasn't a picky eater in general. Bite marks on Triceratops frills, crushed Edmontosaurus tailbones, gnawed bones showing repeated feeding at the same carcass, all of it points to an animal built to consume almost everything available, meat, bone, and all, with a bite force strong enough to crush through solid bone rather than just tear around it. Now, flip to a completely different predator, and the diet changes entirely. Spinosaurus. For decades, scientists pictured it as a fairly typical land predator. Then, researchers began finding something odd. Fish scales, preserved directly in the stomach contents of Spinosaurus specimens, along with a skeleton built more like a modern fishing bird than a typical land hunter. A long, crocodile-like snout, cone-shaped teeth perfect for gripping slippery prey, and dense bones that may have helped it stay submerged while wading or swimming through ancient rivers. The evidence points toward an animal that spent a significant part of its life hunting fish, not chasing prey across open land the way it's usually shown. Even the smaller dinosaurs held surprises. Fossilized stomach contents from small feathered dinosaurs have turned up seeds, insects, and even small mammal bones together in the same specimen. Evidence of animals eating whatever was available, rather than sticking to one narrow food type. Some species that were once assumed to be strict meat eaters turn out to have been flexible omnivores, adjusting their diet to whatever their specific environment happened to offer. And then there's one discovery that genuinely surprised paleontologists. Fossilized dinosaur stomach contents have occasionally turned up something almost nobody expected: charcoal and burnt plant matter. Some researchers believe certain species may have specifically sought out land recently touched by wildfire, since fresh growth after a burn is often easier to digest and more nutrient-dense than older, tougher vegetation. If that theory holds, some dinosaurs weren't just eating what grew naturally. They may have been taking advantage of natural disasters as a food source. Put all of this together, and a much more complicated picture emerges than the one most people grew up with. It wasn't simply herbivores versus carnivores, plants on one side, meat on the other. It was swallowed stones, grinding leaves into paste inside a sauropod's gut. It was T-Rex crushing through bone with a bite built like industrial machinery, sometimes turning on its own kind. It was Spinosaurus wading through rivers, hunting fish like an oversized heron. It was small, flexible omnivores eating whatever the day happened to offer, and possibly some species tracking wildfires just to reach easier meals underneath the ash. Every single one of those strategies was solving the exact same problem: how to survive and grow and reproduce inside a body that evolution had shaped in a very specific direction. Whether that meant a mouthful of grinding teeth, a stomach full of stones, or jaws strong enough to end an argument permanently. And maybe that's the real answer to the question. Dinosaurs didn't eat one thing. They ate whatever their specific bodies, environments, and 150 million years of evolution allowed them to get away with. The same rule that shaped what every animal on this planet eats, including, eventually, you.